Hello everyone. So today we are going to work on this fluid flow simulation. So here you can see these cylinders start the fluid start location, and you can see gradually this some oil like fluid is flowing from them. So here it's it's a simulation, so it actually finds the slope on the ground and flow according to that. So see, so we actually using that oil material we created yesterday here. It's not infinitely flowing, I have limited it. So yeah, this is what we are going to work on today, a fluid flow simulation. So later on I plan to implement something like a burning effect. So if I burn this edge, it will keep burning to here. Like, you know, there was a mission in GTA 5 where you can uh, you walk with the oil can and you make a path with oil and you burn a house. I don't remember the exact mission, so actually that's where I thought of trying something like this. So this is not actually, that's a different thing, but here this is like a oil path. So yeah, let's see how to do this today. Right, so this is the oily surface that we created yesterday, the decal. So now what I want to do is creating some oil flow. So a procedural oil flow that may be flowing on the ground according to the slope. So this is a flat ground, so we can't really do like a simulation of a flow rather than just collecting in a single place. So it would end up something like this. So let's create let's go to this open world template, and there we can have some uneven ground here. Go to here. Oh. It's take too long to go there. Right, now if I implement something to simulate a flow, I think I can get it in a place. First, in the blueprints, I'll make flow. So this will be like a starting position for a flow. Could be any flow, not necessarily to be for a flow. So now to simulate let's roll the board to find out the path. I don't think it has to be this part. Well, actually that depends on the character type. Doesn't have to be that part. So small. Right, now when I play, I'll we don't really need to simulate it through code. We can here enable physics. This one. So if I play, now you see the ball is going like that. Okay, so but if I don't think a fluid flowing downhill would follow the same exact path like the ball, because ball can sometimes go upward a bit also because of the momentum. Such a thing would not happen with a fluid. So maybe we should add a terminal velocity. I'm not sure if there is a no. Max angular velocity is there. Don't know if I can set a terminal velocity. Maybe we can increase damping. Okay, so if I place this object somewhere over here, we should see it going in a path like this. Let's see what happens. Yeah, it's going that way. Okay, so now we can we have a way to get some idea about where the oil will flow. Now if I save a series of points, maybe perhaps into an array, so that I can have a list of points that represents the path of the oil flow. So I can spawn a set of decals along that path. If that is not good enough, we can create a spline, and then along the spline, because with the spline we can get smooth curves and everything, so along the spline we can perhaps spawn decals. But first let's see how it looks with saving points into an array. So I'll create a variable path points. This should be a vector array. In beginning, we need a couple of other variables to do the calculations too. So last point, it should be just a vector. So I'll set the last point as actor location, sphere location, get location. That should be the last point. So that we can do some comparisons and figure out whether to add a new point to the array or not. So get the last point and get world location and calculate the distance. So if the distance is, let's say, larger than, I'm not sure, perhaps 30, We can change this value. Let's say point gap. So if this is true, get path points, add a value and this value, not any value, this value. So like this. So we don't need to have an unlimited a very long path. So let's have a delay, maybe 3 seconds, and sphere, get the sphere, so set simulate physics. I'll stop physics simulation, and here let's have another variable called simulating. By default simulating is true. Here let's set simulating to false, just to see if we are getting the lines. Let's draw debug line from whatever this point to upward, so that we can see it, perhaps 50, in the color red. Five, duration 10 seconds should be enough for us to see. Flow path, let me save this level as flow path. Play. Alright, 3 seconds is not much. Well, do I have the third person character here so that we can see the path in perspective relative to the scale? No. Let me add it to the project. Okay, now let's set PP third person and play. Okay, here is the path. Right, now I think we should have more point gap than 30, 60, and also 10 seconds. Well, still they are very close together. Sorry, I forgot to update the last point. Really sorry about that. So set last point with this value. Oh wait, no, with this value, and that should be used. Now one. Now we should see gaps. Yeah. So that's the path with the curve. Okay. Now along that path let's spawn a series of decals. But how do we do that? Right, let's add a custom event, draw oil path, draw flow path, not oil path. And then we do have the points, so let's have point index. This should be an integer, so we are going to place decals around these path points. Get the point index and check the last index of the path points to make sure that we have more path points to be drawn. Right. So if this is true, we can get whatever the point and spawn decal at location. Oh, we need to give a rotation 2, so so instead of considering the last index, let's take last index minus 1. So that we have 2 points to calculate the direction as well. Get the next point, that should be the next point where we draw the decal, and another one, get this point index plus 1 and find look at rotation from here to there. So that gives us the direction, and the decal material, let's see how it looks like by using this, but I don't think this shape would work. Anyway, let's just use it and see. Oh, decal size, $75, $70, $30. I'm not exactly sure. Let's just see. And what else we can do? Set fade in. Oh, we can give a start delay. No, duration. 1 second. And give another 1 second delay, and don't forget to increment this and call again the same function, draw flow path. So this will continue to draw all the points, draw decals on all the points we have in this path points. So let's start this. We don't really have to wait until the simulation is finished, so maybe just 2 seconds so that we have something in our path points row flow path. Okay, okay, we are getting it. Why does it look horrible? We do get the path, but it doesn't look anything like what we expected. How does the decal look like with 7070? What's the scale here? Oh wait, decal size. Right, this is how it's supposed to look like. But why it looks like a square here? Does rotation has something to do with that? Right, let's try it without the rotation. Yeah. So that was the rotation. Okay, so the way we calculate the rotation is wrong. Right. Let's keep this 90 and get only yaw from this to orient it. Okay, I think we do get the direction correctly. It's too slow. Yeah, rotation calculation seems correct. Alright, now let's fix the shape. So in order to get the fade in look, decal this decal lifetime opacity, I think we have to use that. Multiply this alpha with this value and connect. And now see, yeah, now it appears slowly. Okay, now all we have to do is set in the shape. So this is the current shape I have. This is 124. So the middle is 512, and let's just create a rectangle like this and give some randomization. Not much, a bit. Hope that wouldn't be too much. I'll save this as oil path alpha, and import it here, oil path alpha. So instead of this m oil, I'll convert this to parameter oil path alpha and apply, and let's create a material instance. Here I'll replace this oil path alpha. Instead of oil puddle, I'll use oil path alpha to define the shape, and here instead of m oil, I'll use m oil mi oil path. Okay, now let's see. Well, I think it would be better if we just keep it straight, because we see a clear pattern. So yeah, like this. Save and re-import. One more thing, we should match this fade in durations and this one. It's already matched. Okay, now let's see. Alright, so we do get the path. But still I'm not happy with the way it appears. Let's try something like this. Texture sample. Let's add some noise texture here, like this. Oh, a darker one. Perhaps this one. If I apply this, the decal would look like something like this. Right, so we need more black. What about this one? Okay, if I add these two together and multiply, we should have some fade in, a better fade in type of a look, but also we might need to increase the fade in duration. Let's say 2 seconds. No, no. Let's see, let's get the texture coordinates and do a component mask and get R. So if I add this factor also, would I see some difference? Oh, it's reversed. Okay, so it's reversed. 1 minus. Let me just simulate, so I don't really need to see the character. Okay, now we do get the flow in, but we get the character, it snaps. But we get the decal is snapped in place. So let's multiply this again. So the total value also get affected. Yeah, now it's better, see. Good, now it looks like actually flowing. Apart from this edge, sharp edge. Yeah, so okay, that's good. Let's slow this down also. Right now we see a sharp edge here before the other one starts. That looks bad. So even though I did say like oil shouldn't have a fade in, for this let's add some fade in effect to make it smooth in the edges. So mask gradient from the middle. Oh, it should be inverted. To be able to see it clearly, let me make the background black. Right. Do we have a sharp edge here still? A bit, yes. So to get some randomization, let's use this same one here. Let's get a snapshot of this and paste. This is only to get the shape, so transforming it wouldn't give us any problems. And let's use the multiply. Right, now we don't have such a sharp edge. Let's save this. Oh wait, Yeah, let's save this. And we might need to change the material because we have black here now. I don't know. Yeah, let's use one of these channels, maybe R. Did I apply here? Oh, we need to re-import this. Let's use this soil path instance. Alright, now this is the shape we get. Okay, I think that looks better. Yeah. Now let's simulate. Okay. So perhaps we need to half this distance gap. Let's try 30. And one more thing, now let's disable this debug line. We don't need it. Okay, I still need to do some adjustments to increase because I feel like we have too much opacity. Yeah, we need to get rid of these black patches, so that's what causing the gaps. So let's use this patch to somewhat get rid of these black areas a bit, not all together, just a bit. Okay, save. Import. Oh, here. Yeah, now it looks more consistent. Okay, let's see. Okay. One more thing, let's try increasing the scale. Oh, wait a second. Now it's working. Okay, good. Now if I reduce this speed, we can increase the flow speed and it should still look good. See, maybe it's still better to slow down, but we have something now. One more thing, if we need to give some randomization, because I can see still some pattern here. See, I can see a clear pattern, so we still need to even out this. Right, now we don't see much of a matter, and I'm gonna stop this episode right here. So here we have this oil flow. Only one thing we have to do, we don't really need to see this ball, so we can make it hidden in the game here. And also after finishing the simulation, we can even disable the collisions if it interfere with the characters, but for now I don't have such a problem. So here is the final preview of the oil flow. Right, if I add one more of these characters here and here, I should see how it adapts to the ground. Properly. See, these two get merged also. But they are not get merged and follow the same path because of the properties of the ball, simulating ball. Maybe if we increase the damping, let's see, keep the visibility also. Now it's moving too slow or slowly, so which is more like a ball, sorry, a fluid. Oh, it doesn't flow much. Yeah, see, we have even some curves. So yeah, Now if we need to have a longer line, what we can do is simulation time. Let's have like 50 seconds. Yeah, see, these two almost get merged, more like a water flow. Not perfect, but yeah, it's something. Down the line, these two also get closer and merged, but the simulation is stopped here. So yeah, I think with this we can stop this episode right here. So thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.